carbon bound to the heteroatom is singly bound to the heteroatom, that is called the alpha carbon. Not so when the carbon is multiply bound to a heteroatom. So in the case of these aldehydes, this carbon is called the carbonyl carbon, mentioned that earlier. The carbon bound to the carbonyl carbon is alpha, and this is beta. Okay? This is the carbonyl carbon. That's the carbonyl carbon. And this is the alpha carbon. Carbonyl, this is alpha, beta, gamma, delta. And this I call alpha prime. Right? Carbonyl, these are alphas, and then beta, gamma, delta. So it's beta, beta, gamma, gamma. There's no delta. Oops. This is gamma here, this is delta. And same thing on that side. Okay? So this is different in how we categorize and how we label the carbons. So when the carbon bound to the heteroatom is singly bound to it, it's called the alpha carbon. And then the ones attached to it sequentially are beta, gamma, delta. When the carbon is multiply bound to a heteroatom, it takes the name of the functional group. So in this case, the carbonyl carbon. And then the ones bound to it are alpha, beta, gamma, delta. Other examples of carbonyl compounds. Other examples of compounds that contain the carbonyl group, which go up one oxidation level, as it turns out. They are R, C double bond O, let's say X, where X is equal to a halogen. These are called acyl halides. Okay, it's called acyl halides. R, C double bond O, N, I'm going to write NH2. These are called amides. We'll come back to this in a second. R, C double bond O, O, R prime. These are called esters. Come back to this in a second. R, C double bond O, O, C double bond O, R prime. These are called acid anhydrides. And all of these are born from, or can be born from, these compounds, which are called carboxylic acids. And carboxylic acids are considered the parent of this set. So I call these things, they're all carboxylic acid derivatives. Because in the bad old days, and even now, you could make them from the carboxylic acid. So I've got acyl halides, they're sometimes called acid halides. I think both terms are interchangeable now. There are amides, esters, acid anhydrides. Okay. Amides can be subcategorized based upon the number of carbons on the nitrogen. So if I have this structure, these are primary amides, and it depends on where you're from. Some people say amide, some people say amide. These are primary amides, or amides, which are different from secondary amides. Right? These are primary, these are secondary, and these are different from tertiary amides. And I'm going to put prime and double prime in these because the R groups may or may not be the same. Same thing with the esters and the anhydrides. Right? The R groups could or could not be the same. So why don't we draw examples, instead of having variables like R and R prime, draw some examples of, say, acid halides and so on. Oh, yeah. With acid halides, this R must be an alkyl group. It must have carbons. With amides, this could be R or H. Same thing here, R or H. But if I'm going to do secondary, then this has to be a carbon container. This can be R or H. With carboxylic acids, this can be R or H. With esters, this is interesting, this can be R or H, this has to be R. And then this can be R or H. And guys, let me just say, I know this is confusing. But trust me, it's something you have to go through. Because you can be asked to draw a chart of an ester with a certain formula, or an anhydride with a certain formula, and the chemistry of esters and hydrides and amides and carboxylic acids vary dramatically. So you can't, this is not a trivial concern, okay? So let's draw a couple of examples. So let's start with the parent, if you will. So the simplest carboxylic acid would be HC-O-OH. That's called methanoic acid. In the bad old days, it was called formic acid. So it's methanoic acid. It's also called formic acid. It's called formic acid, by the way, because it's one of the compounds found in ant venom. So the Latin name for ant is formica. And one of the compounds in ant venom is formic acid. Formic acid is not an incredibly strong acid, but it has the capacity to penetrate deeply into animal tissue. It's really quite a nasty compound. And it's called methanoic acid because it only has one carbon. So meth implies one carbon. So that's a carboxylic acid. Then of course I can draw this. Or this. All of these are examples of carboxylic acids. Okay? So this group can be R or H. As I said with acid halides, you have to have a carbon attached to the carbonyl carbon. You can't have H. This species has no real existence. Right? It decomposes immediately into carbon monoxide, right? Into carbon monoxide and HCl. So this species has no real existence, right? It just immediately fractures. So I must have at least one carbon to anchor it. So that's an acid halide. So is this. Right? All of these are acid halides. Amides could be, I can actually have this, right? That's methanamide. And I can have this. I can have this. So that's an example of a primary amide, secondary amide, and a tertiary amide. And then esters must have an alkyl group on the O. So if I have this, that is an ester. If I switch the groups around, so I have this, so these are isomers, that's a carboxylic acid. And the chemistry of these could not be any different. This one dissolves in water, this one does not. This one smells sweet, this is vinegar, so it has a pungent smell. This one reacts with metals to give you hydrogen gas. This one does not. So the chemistries are wildly different. even though they're isomers and the structures look very much alike. They're not. Right? So this is an example of an ester. Right? It's R, although this case R can be H. R, C double bond O-R. Right? That's an ester. That's a carboxylic acid. This is R, C double bond O-H. And I'll say it again, I recognize this is, they don't look as if they're that big of an issue. It is a big issue. And then finally there are where am I? Right. Finally, there are anhydrides, and I'll just draw a couple examples of those on the board, and then we move on to the last piece. So go to draw an anhydride. They are, this is an example of an anhydride, or I could have the simplest one would be this compound. These are H's. But anhydrides can also be what we call mixed anhydrides. So these are what you might call symmetrical anhydrides, because the two R groups are the same. This would be a mixed anhydride because the R groups here are different. Okay? All right. The last point we make, and then we stop, is you remember when we classified the alpha and beta and so on carbons. So for example, if I imagine this compound, and I call this carbon, if you remember, the alpha carbon, and then this was beta, gamma, delta, epsilon. Well, it turns out the H's on the carbons take the designation from the carbon. What does that mean? Well, I know that there are two H's in this carbon. So these are called alpha hydrogens. This carbon is the beta carbon. The H's on it are called beta hydrogens. These are gamma hydrogens, delta hydrogens, epsilon hydrogens. The ones we tend to be most interested in are the alpha and the beta. In the same way, if I have an alkene, I call these carbons the vinylic carbons. So the carbons of the double bond are called the vinylic or the vinyl carbons. The H's attached to the vinylic carbons are called vinylic H's. So these are called vinyl or vinylic H's. So these are vinyl or vinylic H's. I will point out that a carbon attached to a vinylic carbon is called an allylic or an allyl carbon. This is the allyl or the allylic carbon. Guess what the H's on the allylic carbon are called? Not surprisingly, these are called allylic or allyl H's. And finally, if I have, for example, a terminal alkyne, then this is called, because these carbons are called acetylynic carbons, the carbon attached to, the H attached to it is called an acetylynic H. So the H's take the name, or for that matter, the group takes the name of the carbon to which it's attached. So for example, this compound is often called vinyl chloride. It's the monomer used to make PVC. PVC is polyvinyl chloride. Because it's vinyl, and I've got a chlorine on the vinylic carbon, so it's called vinyl chloride. Okay, I think that is where we will end. Yes. So next lecture we talk about organic nomenclature, and we go from there. I cannot stress enough, and I'll give you guys a worksheet to try, although you have some of the questions in your homework have questions on the functional groups. I cannot tell you how important it is for you to be able to recognize functional groups and to identify them in organic compounds. So this is something, there is some systematic sort of logical approach to this, but honestly guys, a lot of this is stuff you got to learn. This is the language of the science. And I mentioned that to you guys before. In many ways, chemistry, organic chemistry in particular, is like learning a new language. And you can't go to France or Germany or Switzerland and not know the words for airport, cab, hotel, embassy, restaurant, right? You just won't survive. You will not survive organic chemistry if you don't know the vocabulary. And you just have to learn it. As I said, some of it is systematic, but a lot of it is just the names of the compounds and the classes. You just have to learn them. So happy studying, and the next lecture will deal with nomenclature. Great.